Alright, 7th graders, today we're talking about perimeter and area of similar figures. Your essential question is, how do changes in dimensions of similar geometric figures affect the perimeters and the areas of the figures? There's not anything that we need to memorize because we can check each and every time how they're related. So our first question is, what is the ratio of perimeters of similar figures? So if two figures are similar, then the ratio of their perimeters is equal to the ratio of their corresponding side lengths. That said, the perimeter of ABC over the perimeter of DEF, they're always going to be similar. So if this AB was 1 and this was 2 and this was 4 and 5, the ratio here would be 1 to 2. B to C would be 4 to 8. And this one would be 5 to 10. And they're all similar. So the ratio of the perimeter, then this perimeter is 10 and this perimeter is 20. The ratio of the perimeter is equal to the ratio of the side lengths. So if the side lengths are 1 to 2, so is the ratio of the perimeter, which is 10 to 20, which reduces down to 1 to 2. So you don't actually have to find the perimeter. All you have to do is find the ratio of the side lengths when it's all said and done. So let's take a look at the first one here. Find the ratio, red to blue, of the perimeters of the similar rectangles. So the perimeters would be, the ratio of the perimeter would be 4 to 6. Okay, so the perimeters ratio is just the ratio of the two sides. And in this case, we wanted to do red to blue, so I have red and blue. You can reduce this to a ratio of 2 to 3. The height of figure A is 9 feet. The height of a similar figure B is 15 feet. What is the ratio of the perimeter of A to the perimeter of B? We don't even need to know what the shape is, because we know that the ratio of the perimeters is the same as the ratio of the side lengths. So in this case, we have 9 to 15, which can be reduced if we divide by 3 to 3/5. Areas of two similar figures are different from perimeters. Perimeters are exactly the same. If two figures are similar, then the ratio of their areas is equal to the square of the ratio of the corresponding side lengths. So, if the side lengths happen to be 2, 5, and 7, and 4, 10, and 14, those would be similar figures. The ratio of the areas would be 2 squared and 4 squared, because the ratio is the squares of the side lengths. So it would be 4 to 16, or 5 squared to 10 squared would be 25 to 100. Alright, so let's try at least one of those. The ratio, what is the ratio of areas of similar figures to the red and blue triangles? Well, the red triangle has a side length of 6. The blue triangle has a side length of 10. And for the areas, we square them. So we would have 36 over 100, which would reduce down to 9/25 if we divide them both by 4. The perimeters, though, would just be 6 to 10, which would reduce down to 3 to 5. Alright, you have 6 problems to try for homework. Again, the perimeters are just the ratio of the side lengths. So on number 1, 8 to 3 would be the perimeters. And the area, the ratio of the areas would be 8 squared to 3 squared. So that's all you have to do for each problem. Finish those for homework through number 6 and have a great night.